When you're trying to find a missing angle measure of a right triangle, you need to know one of the acute angle measures, and that'll help you find the missing one using the triangle sum theorem. But if you have a situation like this where you're solving for x and you don't know the other acute angle measure, it doesn't matter that you have two side lengths because you can't use triangle sum theorem to find x. So we're going to need to have something new to help us figure out what x is. So what we've learned so far with our trigonometry unit is that the Pythagorean theorem and trigonometric ratios, sine, cosine, and tangent, help us find missing side lengths in right triangles. And we know that the triangle sum theorem helps us find missing angle measures in any triangle when we already know two angle measures, which is pretty cool. But it won't help us with a situation like we saw on the previous slide. So when triangle sum theorem doesn't work, we need another way to find that missing angle measure in our right triangle. And so that leads us to inverse trigonometric ratios. So inverse trigonometric ratios help us to solve for a missing angle measure of a right triangle when we already know the length of at least two sides. So we could either know 2 or 3 side lengths, and then we could figure out the missing angle measures in that right triangle. And that missing angle measure will never be the right angle. Just like with trigonometric ratios, the reference angle was never 90 degrees. The missing angle is never going to be 90 degrees for inverse trig ratios. Those inverse trigonometric ratios literally are the inverse of your trig ratios. So you have sine inverse, cosine inverse, and tangent inverse. Sine inverse is also referred to as arc sine. And to find sine inverse, or if you take sine inverse, it helps you find theta, your missing angle measure. And to do that, you do sine inverse. This little -1 is the notation for an inverse, and it's superscript, so it's a little bit above, right? It's not -1, it's sine inverse of the length of the side opposite theta divided by the length of the hypotenuse. And that gives you a number, and that number is equal to your missing angle measure. So this missing angle measure is found by doing sine inverse of opposite divided by hypotenuse. You also have cosine inverse, which people also call arc cosine. And to find theta this way, you would do cosine inverse of the length of the side adjacent to theta divided by the length of the hypotenuse. So cosine inverse of adjacent divided by hypotenuse gives you the angle measure. And our last inverse trig ratio is tangent inverse, which is referred to as arctangent as well. And that's found, your theta is found by doing tan inverse of the length of the side opposite theta divided by the length of the side adjacent to theta. And when you do that, that's going to give you a number which is equal to theta. So if you notice, we're still seeing those relationships with our trig ratios, right? So ka toa, we're seeing the opposite over adjacent for tan inverse, but it's a little different. So make sure you're seeing that difference as we work throughout this lesson. Some important things you need to remember. These are only used, inverse trig ratios are only used for right triangles. They're used to find missing acute angle measures, and the ratio of the sides goes in the parentheses. Also, don't forget the -1 notation to show that you're taking the inverse. On your calculator, you're going to be making sure your calculator is in degree mode, and that's only for this course because in upper level math courses, you will be dealing with radians as well, but we're only dealing with degrees here. To get to your inverse trig ratios, you just need to type second, and then whichever trig ratio you're taking the inverse of. So if you're doing sine inverse, you would do second sine. And if you look at the right above sine, cosine, and tangent, you'll actually see sine inverse, cosine inverse, tan inverse written there. And if you didn't know this about your calculator already, it's color coordinated. So if you're trying to get sine inverse and it's in blue, that means you have to hit this blue second button to get sine inverse. Your colors may be different, but that's how the calculator is organized. So that's just a brief introduction into inverse trig ratios. In your next video, you're going to see some examples about how to use that.